Hi guys and gals, Mr. Tima here. I'm going to talk to you a little bit about covalent and ionic bonds. You're going to be watching some videos, and you've probably already seen one by a guy named Tyler DeWitt. He has a lot more visuals than I'm able to do, much more technology and setup, so please use those notes. They are awesome. Some things that he's going to say in his videos, though, that are a little slightly different than what my notes say, is the word covalent. Okay, he doesn't tend to use the word covalent very much. He uses the more proper word of molecular bonds. Okay, but he uses the word ionic. So just realize when he uses the word molecular, he's talking about covalent. What we need to understand about this is very simple. Some highlights that I want to make sure that you understand is the word covalent. Okay, the word covalent has that co in it. And co means like together, okay? We are talking about sharing. We're talking about sharing electrons here. They are working together. As you notice right here, you can see that these things are sharing these back and forth. And he does a much better job than I do explaining it. Biggest thing is, it is the bonding of a nonmetal and a nonmetal. And you have to understand that that has to deal with the staircase. And again, watch his video. He does an awesome job of explaining that. Ionic bonds, okay, literally when you hear that word ionic, okay, we're talking about just me. I'm taking something. There's not sharing going up. Things are being given up, like right here, this is being given up to be part of it. And there's some really big misconceptions about these outer valence electron shells and stuff. And there's also, I put some help video links on there. So again, but the biggest way we can tell is it is the bonding of a nonmetal and a nonmetal. Okay, so really right here again on your notes, make sure you look at that, but imagine that if this electron was going around here and this electron was going around here, and you were to take a photo, we would see that electron somewhere around each of these at any time. But when they covalently bond or molecularly bond, those two electrons could be anywhere around these two guys at any time because they're being shared. Okay, while in an ionic bond, a very possessive, a give up to be part of it, he's giving that up, and only the electrons will be around this guy. Okay, so real quick, take a second, check yourself real quick. Which one's covalent or molecular, and which one is ionic? Hopefully you're focusing in on how these are moving around versus these guys that are being shared. So yes, this guy would be ionic, and this guy would be covalent. Okay, so hopefully you saw that. Quick refresher on what a compound and a molecule is. Just need to make sure when we're saying these terms we know that a compound is two or more elements combined together. So again, hydrogen and oxygen, carbon and oxygens. While a molecule is two or more of the same atom or element bonded together. So O2 is just oxygen, and H2 is just hydrogen. All right, this is a very important slide, okay? Probably one of the most important and one of the most that they're going to spend the most time in the video on as well, okay? So making sure we understand this. But the idea or the term of anions versus cations. Anions are negative. So when something becomes an anion, it becomes negative. Okay? That actually means it has extra or more electrons. Now this is what's hard, is because you guys are programmed to think that subtraction equals less. That's actually wrong in this case. Subtraction or negative is equal to more. Okay, because we're talking about negative electrons here. Negative electrons. So the more negative we are, the more electrons we have. Okay? While a cation or a cation is positive in nature, which actually means it has less electrons. Because again, when we see, since you've been programmed for math, that means more. But that's not what we're talking about. We're talking about positive charge, which means that there is actually less electrons, okay? Because electrons have a negative charge. Again, as you watch the other videos, this is going to help and make more sense as we do it. Mathematically, if you want to look at it, there's this slide right here. And just to be quick about it, basically protons minus electrons equal ionic charge, or P minus E equals the charge. So in a standard neutral lithium atom, all right, there are 3 protons, which means there should be 1, 2, 3 electrons, and there is. So 3 protons, positive 3, minus 3 equals a charge of 0, so that is a neutral atom. Now this lithium plus 1, this is an ion. Well, how do we know that? Because it has 3 protons. It should have 1, 2, it should have 3. It should have 3 electrons. But this electron is gone. This guy's gone. Okay, and so since this is gone, we have our 3 protons still, but only 2 electrons. So 3 minus 2 is a positive 1. It's a positive ion, or what we would call a cation. Okay, and the reason it's positive, even though we lost something, is because remember, we lost a negative thing. And since we lost a negative thing, we become more positive. This is the one I wanted to slide my stuff up on here. Okay. All right. Real quick, and he's going to cover this in his video as well. But if we look at this, think of sodium. All right. Think of sodium here. Sodium's right here on the periodic table. Sodium has this 1 outer shell electron. Now you got to ask yourself a question. To be, let's say, happy or complete its mission in life, it wants a full outer shell. So it can either journey across the periodic table and be like argon and gain 7 electrons around its outermost shell, or it can just lose this 1 electron, lose it, and go back and kind of be like neon. All right? Well, think about it. Would you rather do 7 things or do 1 thing? The answer is 7. You'd rather do 1 thing. Everybody's lazy, right? So if we lose this electron, we're losing how many? We're losing 1 electron. And if we lose a negative thing, if we lose a negative electron, then we're going to become positive. Oh, that's kind of hard to read. Sorry about that. Let me erase that real quick. If we lose 1 electron, it's going to become a 1 positive charge, or as we'd say, a cation. All right, let's look at boron real quick. Let's look at boron. Same idea. Okay, same idea. Boron is right here. Would boron rather gain 1, 2, 3, 4, 5 things, or would it rather go back 1, 2, 3 to be like helium? Well, it'd rather go back 3 than do 5. It's a numbers game. So how many is it going to lose? It's going to lose 3. And if it loses 3 electrons, it's going to become 3 positive. Okay? Now chlorine gets closer over here. Chlorine's right here. All right? Chlorine is right here. It has 1, 2, 3, 4, 5, 6, 7 outer shell electrons. Now, would chlorine rather gain 1 electron or lose 7? Well, just like before, it would rather gain 1 rather than do 7 things. So how many electrons are we moving or whatever? Well, we're trying to gain 1. So we're going to talk about 1 electron, and since we gained 1 electron, which is negative, it's going to become 1 negative charge. Oxygen. Oxygen. Let me erase these. Sorry about that. All right, look at oxygen. Oxygen's right here. It would rather gain 2 than try to lose 6 and go backwards to be like helium. So it would like to gain 2 electrons. So it's becoming 2 negative things are coming in there. How many electrons? 2. So if it became 2 more electrons on there, it's going to become a 2 negative charge. Again, make sure you watch this guy's videos. It's really going to help you out. And just like before that you should have learned about the ionic charge numbers, we should have learned we should have learned by looking at the ionic charge number, or excuse me, the valence electron numbers, we should then be able to look at the periodic table and determine what those electrons would want to do. So since these guys have 1 valence electron, 2 valence electron, 3 valence electron, 4 valence electrons, 5, 6, 7, 8 valence electrons, now we can kind of say, well, if everything in this column, if everything in family 1, the alkali metals, has 1 valence electron, then it would rather give that up than gain 6. So that means everything in this family would become 1 positive because it wants to give up 1 electron. Everything in this family would want to become 2 positive, 3 positive. Now, everything in the noble gases is full. So since everything's in the noble gases are full, we can just say that they don't want to do anything. They don't have a charge. They're happy. Everything in the halogens, okay, has 7 valence electrons. So it would rather gain 1. So if it gained 1, we become 1 negative. Everything in the oxygen family would rather gain 2 negative. Everything in the nitrogen family wants to gain 3 negative. And then we get to the magical carbon family. I should say valence electron, sorry about that. All right, but the 4 can go either way. So it could be 4 plus or minus. They can kind of go either way. All right, so they're kind of a little bit confusing like that. Again, make sure you watch the other videos with Tyler DeWitt. He has a lot more visual to this, but hopefully this helps clear up some of your thoughts. All right, have a great day.